Here's the Eveready power supply again on my bench. And I have the parts that I'm going to use to rebuild it. Not much involved here. Here's the new power cord I got from Vintage Wire and Supply. Very nice. Even though this cord could be reused, it is in actually pretty good shape. I like the looks of this this new cord. Plus I got a reproduction plug. It's not exactly the same that was on it, the one that got crunched. This is an acorn plug. The one that was on it, I couldn't find a reproduction of that one, but this one comes close to it. It's also polarized. And here are four 4.7 microfarad at 450 volt electrolytics. I'm going to try to use all four caps that are supposed to go in this. There originally was a 1, another 1, and then a 2, and then a 4. But I'm going to try using all 4.7 mic capacitors. If you look at the power supply from the picture that I have, it's a typical Pi network filtering system on the power supply. A Pi network, 2 capacitors to ground on each side of a choke. So I'm hoping that these caps will work. We'll see. Once I get them in, we'll see how they work, and I think they will, but we'll find out. I finished working on the Eveready radio power supply. I have my new cloth covered cord wired in. I have cable ties on both sides to make sure that it can't be pushed in or pulled out. The new reproduction plug on the end, and put a little black tape around it to make sure that this brown cloth sleeve doesn't come up from the rubber inside, because inside this rubber sleeve, this cloth covered sleeve, is a rubber cord, a gray rubber cord. It's actually very nice. I could have got by with the old cord, but I think that I would have been best off putting this new cord, and I got this giant capacitor out of it. This is an 8 mic and 4 section capacitor. 1 mic, 2 mics, and 4 mics. So I'll show you what I did underneath the chassis. Here's the underside of the chassis. Notice that I use shrink tubing on my power connections here. The original power connection was routed over the top of this big 10 watt ceramic resistor, but I've got it so that it will be underneath. It's not going to hurt anything being underneath. Heat goes up. I didn't want those wires laying on top of that or being on above that big resistor. Here are four 4.7 mic 450 volt electrolytics. Now, of course, the original capacitors were 1 mic, 2 mics, and 4 mics. I'm hoping that using all 4.7s, essentially 5 mics each, is going to actually work. I can't say. If you look at those little capacitors and look at this big clunker I just took out. Now, I know this is not an electrolytic. I don't think they had electrolytic style capacitors back in 1929. This radio was actually made, I think, in 29, because this capacitor has a date written on it of 1929. So I think that this is the equivalent of what they used to put on electric motors, or they probably still do, but like an oil-filled capacitor. I can't say, but I know I'm sure this is not an electrolytic. It's not polarized. At least I don't think it is. But these new ones are, and they're 450 volts. That should be adequate voltage, and they're all four are 4.7 mics. I think I could have probably found 1 mic and 2 mic capacitors, or 2.2 at least, at 450 volts, but the supplier that I got these parts from had that. This was the best I could do, and I didn't want to order small quantities from other suppliers. So I'm going to hope that this works. This is these two capacitors here, this one, and this one is our pi network. They are connected on either side of the choke to ground. I've already verified that I have a solid ground. I have a wire connected to a soldered on terminal here. That's original. And I checked with my ohm meter to verify that I do have a solid ground. These all terminate at that same ground point. So the next step is to test it and see if I get DC volts out. Okay, I'm going to run the power supply up again. It works. I get B plus out. I'm measuring B plus on the field side, and I have the switch in the magnetic speaker position, meaning that there is a 10 watt resistor across what would be the output to the field winding, so that there's no field needed to run this power supply. And I'm measuring right the B plus that comes right off of that pi network power supply. Now, something interesting, when I first tried this is the original 80 tube that was in there, and it looks to me like it was a replacement that somebody tried and it's burned out. Now, why would an 80 rectifier tube burn out? Well, very simple. Remember, this big capacitor, this lead is 825 ohms to ground, shorted. And that's a heavy load, and this goes right, this lead connects right to the output of the 80 tube. It's the B plus out. The choke would go across these terminals. This was originally a 2 mic and a 4 mic and a 2 mic capacitor. So what happens is you got a heavy load on the rectifier tube, and of course it burned it out. So I have another 280 in there, and I'm going to switch power on and bring her up. Now we're starting to get action because our filaments are warming up in the 80 tube, and we'll bring her up to 120 volts. 360 volts B plus DC, and that's pretty good. So this power supply, I think, is about ready. We'll the next phase is I'll get into working on the radio part of this work. I'll be working on the radio portion of the radio itself.